quadratic functions in factored form. In order to make good use of quadratic functions in factored form, we solve quadratic equations. And the first thing we need to know is what's the difference between a quadratic equation and a quadratic function. Quadratic equations have the form ax squared plus bx plus c equals 0, where a can't be 0. Each term has a unique name. The ax squared term is called the quadratic term, bx is the linear term, and c is the constant term. There's only one variable in a quadratic equation, so if you look up here, instead of writing f at x equals or y equals, we've replaced that with equals 0. Okay? In order for it to be a quadratic equation versus a linear equation, we have to have this ax squared term. It has to be there. We might not see the bx, we might not see the c, but we have to see the ax squared term. Okay? Now, we solve quadratic equations, we can graph quadratic functions. So we need to know the difference between them. If I look at this first equation, f at x equals x squared minus 6, I can see I have two variables, f at x and x squared. And I also have a quadratic term, which is my x squared term. And I do have a constant term. If I look at this second part B, second example, I have f at z, which is like y, and that equals square root of z. So there are two variables, but there isn't a variable that represents a quadratic. Negative 3x equals 0.5x squared. If I consider this equation here, I see an x and an x squared. So there is still only one variable, so it can't be a quadratic function. It could be a quadratic equation. And if I rewrite that and move everything to one side of the equal sign, so if I add plus 3x to each side, I will end up with 0.5x squared plus 3x, which has a quadratic term and a linear term, and it is in fact then a quadratic function. If I look at part D, I have f at t, which is like y equals, and I have another variable, which is the t. So it's definitely a quadratic function if it's quadratic. And if I look at it, I can recognize it is a quadratic function in vertex form, where the vertex has coordinates 1 and 5. Part E. Again, if I look, I have one variable. It can't be a quadratic function. Could it be a quadratic equation? I do have a quadratic term, and I do have a constant term. But they're in the denominator of what's called a rational variable expression. It's not quadratic because it's 1 divided by a quadratic function. Part F. I have an x squared, a quadratic term, a linear term, and a constant term, so it's definitely quadratic, but I only see one variable, so it's in fact a quadratic equation. Now, when we solve a quadratic equation, that means we're trying to find the value that makes an equation like f or c true. Sorry, I couldn't remember which ones were quadratic equations. So we're looking for one unique value that makes the equation valid. So what I have to do is I'm finding the x-intercepts or zeros, the roots, the point of intersection of the x-axis and the corresponding function, by starting with an equation like this one here. If AB equals 0, what can I conclude about the value of A and the value of B? Well, if I look at that, I know from our discussion in class yesterday that AB equals 0 tells me A is 0 or B is 0. If I extend that further even to be A plus C, sorry, I'm not very good at drawing without the Moby, to B plus D equals 0, if I work with that, and if I look at this now and I use what I just had there, that would be like our A, and this expression would be like our B. So I can say A plus C equals 0, or B plus D equals 0. And then I have two linear equations that I can solve and determine what value will make my equation true. For example, if I look at the quadratic function, f at x is 3x times x minus 4. If I want to state the y-intercept, I know that's looking for f at 0, because my y-intercept occurs when x is 0. So I just look and I say, well, that's 3 times 0 times 0 minus 4. And since I'm multiplying a bracket and 3 by 0, I don't have to do any more work. That tells me my y-intercept is 0. And if I look at the f at x equals 3x times x minus 4, to find my x-intercepts, I just say 0 is equal to 3x times x minus 4. And I'm going to scroll down a bit here because the answers are hidden under the screen again. And it'll be a little neater for you to read. Oh, and I didn't do the work. Sorry, guys. I'll go back to writing it. So now I'll branch this off, and I have two solutions. One where 3x is 0, and I divide both sides by 3, because that's how I have to solve this type of equation, because I'm trying to eliminate the multiplication. So x is 0. And then the other one I do, I take my other factor, which is x minus 4, and set it equal to 0. And in order to solve that, I have to add 4 to each side. So x is 4. And therefore, my x-intercepts, or zeros, or roots, are at 0, 0, and 4, 0. Finally, before you come to class tomorrow, please work on exercise 2, page 2, number 1, 2, and 5.